I've written up here the formal definitions for a function to be increasing, decreasing, or constant on an interval. So first of all, we're going to let I be an interval that's in the domain of f. Now, just saying it's an interval, it could be an open interval that did not include its endpoints. It could be a closed interval that did include its endpoints, or it could be half open, half closed. So I could have from A to B, not including the left endpoint, but including the right endpoint, or I could have from A to B, including the left endpoint, but not the right endpoint. The word interval encompasses all of those possibilities, and it also encompasses the possibility of an infinite interval. So we could have negative infinity to infinity, or we could have one of the endpoints being infinite and one being finite. So lots and lots of possibilities there. Okay. One thing that's super important about these definitions is that they are definitions about increasing, decreasing, and being constant on an interval. There is no definition of what it means to be increasing at just one point. At just one point, the function isn't doing anything except being what it is. We're always talking about how it's changing by comparing 2 points, and we've got to have those 2 points be in some interval. Okay. So, for increasing, we say we're going to be increasing on the interval if f of x1, I'm going to just draw something that is increasing. Okay. F of x1 is less than f of x2 for all x1 less than x2 in the interval. Okay. So, if I have two x values, x1 and x2, this is saying x1 has to be smaller than x2. So that's going to be my leftmost point. And then f of x1 and f of x2, that's talking about my y values. So this point here would be x1 comma f of x1. And this point here would be x2 comma f of x2. Okay. So if I put my fingers down on the graph, and I put this finger from my left hand on the leftmost point, and this finger from the right hand on the rightmost point, the left hand is lower than the right hand. This just says the left point has a lower y value. Okay. That is the definition of increasing on an interval. I don't say the function is increasing at x1 because that's not an interval. But I could say this function, I could actually say this function is increasing everywhere from negative infinity to infinity, because I can see no matter where I put what 2 points I choose, as long as I pick 2 points on the graph, the left point is always going to be lower than the right point. For the definition of decreasing, we stick with the fact that x1 is less than x2. So x1 is still going to be the left point, but if my function is decreasing, now the left point has to be higher. So this graph that I've drawn in red is one that's decreasing for any points. If I put down a finger from my left hand and a finger from my right hand, the left hand's going to be higher. Okay, so that's the definition of decreasing on an interval. And then, of course, f of x is constant on an interval if the y value is the same for all x values in that interval. Now, I mentioned at the end of the last video that there's a sort of interesting technicality here. I want to take a look at a function that we know and that changes its behavior. Let's look at f of x equals x squared. Now, that's this lovely parabola here. And what I want to do is I want to find the intervals where the function is increasing and where it's decreasing. I'm just going to abbreviate that with an up arrow for increasing and a down arrow for decreasing. So for increasing, it's pretty clear to see that we're talking about the right-hand side. Okay? So if I pick any 2 points on the right-hand side, my left hand's going to be lower, because as I move to the right, it goes up, so my right hand is higher. Okay? So I can see that right side is pretty much everything from 0 to infinity. Now I know that infinity gets a parentheses, because we never include infinity. It's not a location on the number line, so we can't include it. Do I include the 0? Well, let's see. I certainly can't include anything to the left of 0, because as soon as I go to the left of 0, if I compare that to 0, my right hand is lower. But could I include 0? Well, if I did, it would have to be my leftmost point. And if I choose anything to the right of that, the right point's going to be higher. So I can include 0. Now, if I look at where my function is decreasing, pretty clearly that's the left side, so that would be everything from negative infinity to 0. And sometimes people will say, well, if you included 0 here, then you can't include it here, because it can't be both increasing and decreasing at 0. But the definition of increasing and decreasing is never about what we're doing at a particular point. It's always about comparing 2 points. And if I were to compare what happens at 0 with what happens at any point to the left of 0, even if it's very close to 0, my left point is higher. So, because the definition is a comparative definition, I can include 0 in this interval too. Now, this does not mean that I'm saying that the function is both increasing and decreasing at 0, because I'm not saying anything about what it's doing at a particular point. I'm saying if I compare two numbers in this interval, the number to the right is going to have a higher y value. And if I compare two points on the graph in this interval, the point to the left is going to have the higher y value. Okay. And that is true. Okay. So very often we can include finite endpoints. And very often finite endpoints will be included in more than one interval. 0 is the location where we change the behavior. Until we hit 0, we were going down. Once we pass 0, we're going up. But that means if I compare the value that I get at 0 to anything on the left of it, it's lower. And if I compare the value that I get at 0 to anything to the right of it, it's lower. Okay. So it's part of both of these intervals. Now, that follows from just taking these definitions literally. Unfortunately, your textbook defines things this way without saying that they're talking about open intervals. And in the homework, in the back of the book where they give the answers to the homework problems, they give everything as an open interval. They don't include those finite endpoints. Well, that's wrong. If the question said list the open intervals where it's increasing or decreasing, then I'd have to say, okay, well, it's increasing on this interval, but to make it open, I'd put a parentheses. But the directions don't say that. So, when you're doing the homework for this section, make sure you realize that posted on Canvas, I've got corrected answers to some of the problems. Any problems that ask about intervals of increase and decrease and where a function is constant fail to include finite endpoints when they should, and I've corrected those solutions. So when you're checking your answers, for most questions you can check your answer in the back of the book, but for anything that's asking about intervals of increase and decrease and where a function is constant, make sure you check the corrected solutions that I've posted on Canvas. I will hold you responsible for following the definition exactly, and that technicality means that finite endpoints usually get included in more than one interval. All right, let's take a look at a couple of other functions. Let's just go through some of our parent functions and take a look at what they're doing. So I want to take a look at f of x equals x cubed, and let's take a look at the reciprocal function, f of x equals 1 over x. So if I sketch f of x equals x cubed, looks something like so. Looks like it's always increasing. So I would say it's increasing from negative infinity to infinity. And it's never decreasing. And it's never constant. It does level out as we pass through the origin, but if I compare the value at 0 to anything to the left of 0 I get negative y values, and to the right of 0 I get positive y values. So we always are increasing, even though it levels out as it passes through the origin. All right, if I look at the reciprocal function, that looks like so. Here, remember, we're reading from left to right, so don't get distracted by these arrows and start going in that direction. That just says it keeps going, so there's graph over here even though I haven't drawn it. I'm reading left to right, we're decreasing. Here, we're decreasing. So it's decreasing everywhere it's defined, but I have to recognize that in going from here to here, I have to jump because these pieces aren't connected. And they're not connected because 0 is not in the domain of this function. So this would be decreasing from negative infinity to 0, union from 0 to infinity. The function is never increasing, and I can't really compare a point over here to a point over here, where it would look like certainly my right hand is higher, but it doesn't make sense to work on the interval containing these points because my function is not defined at 0. And we have to work with an interval that's in the domain of the function. All right, none of the parent functions that we've talked about are constant on any interval. So I'm going to just draw in a function that is constant somewhere. Let's just say I had a function that looked something like this. We'll let this be our f of x. And let's just say this is the point negative 3/2, negative 1. And this is the point 2, negative 1. So I can see this function, we go down, then we're constant, then we go up. So I could say we're decreasing from negative infinity until we hit negative 1, and I'm going to include that finite endpoint, because if I compare the value there to anything to the left of it, my left hand is higher than my right hand. We are constant between negative 1 and 2, and I can include both endpoints there. Because if I compare the value here to anything else in the interval, the y values are the same. And we're increasing from 2 to infinity. Again, include that endpoint, because if I compare this value to anything to the right of it, my right hand is higher. And that's our definition of increasing. All right. There are a couple of problems on the worksheet, but the worksheet also includes talking about maximum and minimum values, which is related to the notion of increase and decrease. So what I'm going to do is in the next video, I'm going to present the definitions for maximum and minimum values, and then I'll have you try the problems that are on the worksheet.